The purpose of this video is to demonstrate how to determine the normal stress at specific locations on a beam using ANSYS Mechanical. The results will be compared against that of an analytical solution in order to verify the accuracy of ANSYS' solving method. The cross-section of the tube is given here with inner and outer diameters, and the load conditions and boundary conditions are also given. So I've gone ahead here and uploaded a tube with identical geometry to that one of the problem statement. And now we'll go ahead and mesh. Now the mesh here looks alright, but we want to make sure that the cylindrical face here is captured extra well, especially since this is the part that we're trying to analyze. To that end, I'll add a couple controls. First, I'll do body sizing, the entire mesh, make it a little more fine. And then I'll add face meshing of these key faces, which are the cylindrical faces that are being evaluated. I'll go ahead and generate mesh. As you can see, this mesh looks a lot better. Now that the part is adequately meshed, we can apply the boundary conditions. The first boundary condition to be applied is the fact that the tube is fixed on one end. We can do this by applying a fixed support boundary condition to this face, and that's taken care of. The next boundary condition is that there's a moment being applied to this face. That will define by component. We know that the moment acts purely in the negative x direction. As you can see, that resembles what you see in the problem statement. Now it is negative 5,000 as opposed to just 5, because first of all, pound force inches, when converted to kips, there's a 1 to 1,000 ratio there. But you have to multiply by 1,000 to get pound force inches. And it's negative because it's just the way the coordinate system is defined in ANSYS. You gotta kind of play around with it to make sure that it's acting the direction you want it to. In this case, based on the face I selected, it thinks that the other direction, counterclockwise, is positive. In this case, we want clockwise for any moment, so we have to be negative. We'll create two coordinate systems at the points we desire. In this case, that is points A and B problem statement. Create the first coordinate system, third coordinate system. I'll define it by global coordinates, and since it's purely moving upwards in the y direction, we can just set the origin at y to be 0.6 inches. As you can see, this is identical to where point B is problem statement. Same thing, and this time get 0.8 inches, find point A. Name that. A, and we can begin preparing for the solution process. So to that end, I created two stress probes, stress probe 1 and stress probe 2. And I changed the location method from geometry to coordinate system. And then for orientation and location, put point A for both. I did the same thing for point B. So now we can run the solution. Now that we have the solution generated, compare the results from ANSYS to that of the analytical solution. In this case, found stress in the direction we care about is negative 18.2 ksi at point A. Compare that to the analytical solution, that was negative 18.19 ksi, which is pretty close. And likely, the error results from early truncation of the area moment of inertia rather than error in the ANSYS solver. Now we can also compare stress found at location B. In the normal z-axis, negative 13.7 ksi, awfully close, negative 13.64 ksi, and again, likely less of an error on ANSYS' part and more of a truncation error on my part, the area moment of inertia.